Okay, so we have focus activity number 3. And this is actually really similar. I did this for a specific reason because we've been talking about domain and range, but on what's coming up Thursday? Your first exam. 2 of the problems I've given you just functions very similar to these, and you'll simply go ahead and tell me the domain and range. Okay, so for some people I know this is still a little bit hazy, so let's take some more time to practice these. Can anybody tell me what would I do for the first one? How wide is that function? Okay, so what are you saying, sir? Okay, you'll notice because of these arrows, you would agree he's infinitely wide, right? He's definitely going left forever. And it might be a little harder to see. He does go forever to the right. Because if I were to look at a tangent line right there, I'll imagine it was tangent at one point. It has a negative slope. It's not vertical. So it's much, much slower, but the graph will continue to push out along the positive x-axis. So he is infinitely wide. But does that mean it's just all reals? Wow, what am I missing? There's a hole, okay, right here. Okay, so what's that value where it happens? The x. Okay, so 1. So I'm going to have to write it negative infinity to 1 union 1 to infinity. Or we could just say all reals except x can't equal 1. Would you guys agree? Yeah. Okay. So has anybody got any questions on that? Okay. Can anybody tell me what would the range be? We got how wide he is. How tall would he be? Okay. All reals. Okay. So negative infinity to infinity. This is what Dylan is telling me. All reals. Is he right? Okay, I heard a yes. He is absolutely correct, but there's something that keeps catching my eye right here. Now, we already looked at the 1 horizontally for the x's. Well, what about this one right here for the y's because of this hole? Why aren't we writing it just like we did the domain? Because the hole is 1, 1. The y value is 1, right? Marion? There you go. You see how because the graph, part of it is a parabola, we have that overlap vertically, like there's an overlap right here. So this point, the 1 isn't included here, but the 1 is included because of the overlap. Yes, okay. So we can go all the way through, yes. Very good, very good. Okay, what about the second one? Anybody help me out with the domain? Hey, Stephanie. Okay, so she says negative infinity to 1? To negative 1. And then union negative 1 to 5. And how would you like me to close those up? Just with parentheses? Okay. Is she right? Yes. Okay. And, this is a lot of times how some people prefer to go ahead and do it. If you're able to just go to the final answer, the condensed answer, fantastic. But, some people, maybe they want to do them one branch at a time. Like this guy right here, horizontally, yeah, he only exists between negative infinity and negative 1. And then this guy right here, the other branch, he goes from negative 1 to 5. Now, is this one of those times where I could just say negative infinity to 5? Again, I keep getting confused. We stop at negative 1 and we start at negative 1.
Yeah.
Okay, at least one of them has to be included. Okay, so with both of those not being included, yeah, we have to leave it like that. Okay, so that's the point I'm trying to make, especially for the exam. If it can be simplified, you definitely want to go ahead and do that. Okay. What about the range? Anybody by show of hands who thinks they know? Okay, Aiden, what do you think? Negative infinity to 3.5 and then what? Not included. Okay, is she right?
Yes.
Yes, she went straight to the final answer. Okay. Now, does anybody want me to elaborate on this, or does it kind of make sense? Yes, Stephanie. Let's elaborate on it. Because this guy right here, vertically, he only exists between negative 3 and 1, right? That would be included and that would not. But take a look at this other one. Okay. What's this arrow telling me? That he's going to just continue forever, right? Okay. Well, if you're looking visually, you can go ahead and see that doesn't this graph kind of absorb the other one? So all these y values are already taken care of for this other branch. And even if, maybe you didn't notice that, let's say you put them right next to each other. So you said -3 to 1 union negative infinity to 3.5. Okay. Again, hopefully if you didn't see the graph itself, you're looking at these intervals and you're thinking, okay, well, this guy only exists between -3 and 1, but this guy exists between negative infinity and 3.5. So this belongs in that other interval. All those values are already taken care of. So we don't need that other one. Is everybody okay with that? Any questions? All right. So go ahead and put that someplace safe. You've now got all three for the first set. We'll take care of it at the end. If we have a few minutes left, we can go ahead and staple those and turn them in. Otherwise, turn them in tomorrow or Wednesday. Definitely by Wednesday. All right. Let's see Piecewise. Oh, and there's one other thing I want to go ahead and show you, because I've already had several students come up to me today, and they were not aware of what the website does. So I just want to go ahead and kind of emphasize that for 1 second. So I'm going to go to classroom.google.com. Okay, I've still got the codes if you, for some reason, have not yet signed up. But here's Pre-Cal IS. All right, I'm going to look like, for example, at the current week, because the last time we met was on Friday the 24th, right? So you take a look, you've got these notes here. Okay, language of functions, piecewise functions, graphs of functions. Those are all the notes that we've either covered or began covering last week. Like the piecewise functions, click on it. Remember, you've got your blank, you got your full, and then you've got the assignment. Okay. But more importantly, your class you already know because I'm always wearing this stylish headset. Okay. But all of these, like for example on Friday, once I started recording. Okay, well, I hope everybody's doing all right today. You can hear my amazing voice at any time of the day or night that you want. Okay, but yeah, so I mean, it's because of school policies and things, and because it would just be weird if I were to set up a camera. Unfortunately, that camera would capture your image. Okay, and like I said, that would just be weird for me to have. So this works out nicely. We can still hear all of ourselves, but all we're going to see is what's done on screen. So anytime you're gone, these videos are there along with the notes if you're not able to make it into tutorials. Even if you are able to make it into tutorials, I recommend, if you've been gone like 2 or 3 days, this is an excellent way to kind of catch up and figure out what's going on. Okay, so I just wanted to go ahead and kind of throw that out there again. All right, and I think we're ready to go. Now, on Friday, this is where we finished. We went ahead, we were given the graph of a piecewise function, and we went ahead and wrote it with the subdomains, those intervals. There's a couple of problems here I'm going to go ahead and kind of skip past just for the sake of time. But they are on the notes. They're already filled out. If you don't have questions, come on in and talk to me. Let's do this. Okay. And if you are not able to make it to the website, right over here on the door, the top 5 pockets, they're labeled Monday through Friday, Pre-Calculus IS. So like for example, if you weren't here on Friday, you can easily grab the notes that are left over there. Also, I only make probably about a dozen extra copies every time I go to the copy machine, so not a lot. So really, it's almost like a lottery if you're able to first come, first serve. Otherwise, I really encourage you to go to the website. Fuas? Yeah, sure. Right over here in the 5th pocket. Okay, so let's go ahead. Given a piecewise function, let's graph it. So let's see. What's this first one right here? Because of the square, he's a what? He's a parabola, so he's a quadratic. The second one is absolute value. And then the third one is, okay, he's a cubic. Okay. So here's the best way I think to go ahead and do this. I think you really want to use a combination of what you know about the graph, the characteristics, but also I would really encourage you use your boundaries provided in the subdomains in those intervals. Okay? Like for example, this quadratic, he only exists less than or equal to what? -1. So if I were to draw a line right here, -1, he only wants to live in this area. Okay, so that's why I'm looking at the boundaries. Those are going to be really important to me. So I would go ahead and plug those in to start getting some points on these guys. So let's call this first one A, or you can call it 1, whatever you like, just so we can kind of keep track of which ones we're looking at. Let's go ahead and plug in -1 into this function. Okay, so when x is -1, what's the y value I get? -1/2 times -1 plus 4 squared plus 3. Okay, so let's see, -1 plus 4 squared times -1/2. -9/2. Oh, I'm glad you went fraction. I love working with fractions. So -9/2 plus 3. So that would be -9/2 plus, what's a common denominator? 2. So that would be 6/2, right? So what's the y value? -3/2. Okay, and you can put that, or if you want to go decimal, that's perfectly fine. So I know that ordered pair would be on that graph. In fact, I know right where the boundary is. Would it be open or closed? A lot of people are saying closed. Well, how would we know? Yeah, because this inequality is telling me, what I would put there because we have equality. So let's see, at -1, -3/2, -1.5, I'm going to put a closed circle. Okay. Now, you don't have a lower boundary, but while you could go ahead and plug in other points and just get some, a really general shape of the parabola, I think it's better. Now let's go ahead and start looking at the characteristics. Can anybody tell me what form is that for a quadratic? Starts with a V. What's a really important point on a parabola that starts with a V?
Vertex.
Vertex form. So you could think of it in terms of, a transformation, because every parabola starts at 0, 0. Okay, and you can just look at how it's been shifted, or, this is your H, this is your K. Can anybody tell me what the vertex is? -4, +3. Because your transformations, you went 4 left and then 3 up. Okay, so 4 left, 3 up. And that is a point on the graph, so I'm going to make him a closed circle. And so now, while you could, again, go ahead and plug in another point just to get it, what's a characteristic of parabolas? They're symmetrical. Okay, there's always going to be a line of symmetry through that vertex. And we know this guy has to open down because that coefficient is negative. So let's reflect this guy over. How far is he from the line of symmetry? 3. So I'm going to go 1, 2, 3 over. Okay. And now I'm just going to go ahead. I know that he can't exist past -1, but forever to the left, he's going to be his normal graph. So probably something like this. There you go. Or, there are other ways. I go ahead and focus on those subdomains, the intervals. So I go ahead and restrict the graph as I create it. But, if you want to go ahead and graph it normally and then just go back and erase the parts you don't need, some people like to go ahead and do that, whatever you prefer. Okay. So A, that first one, is taken care of. We're good to go. All right, let's move on to, let's call it B, because I called the first one A. So now we have the absolute value. Okay. Now, what are some values of X that I can immediately plug in? They're going to be really useful to me. Okay, -1 and 4. Use those endpoints. Okay, use those endpoints to figure out how far the graph can go, and then maybe use a characteristic or another point to get what's in the middle. Okay, so let's start with -1. All right, so we have -1, and then we got to find the y value. So 3, absolute value -1 minus 2 minus 4. Okay, so it looks like I'm going to have 3 times 3 minus 4. What's that going to give me? All right, there we go. So I've got -1, 5. Now, what does the inequality tell me I should do with this point? Make it an open circle, because we don't have equality, right? So -1, 5, I'm going to put an open circle right there. All right. So now let's go ahead and look at the upper boundary for this interval. See, he only exists wants to be between -1, which we already got, and 4. Ooh, kind of move that a little bit. And it's not moving my graph. There we go. Perfect. So let's go ahead and plug in the 4. So when x is 4, 3 times 4 minus 2, the absolute value, minus 4. What will that become? 2. Okay. So I know I have another point at 4, 2. But what should I do with him? He's got to be open as well. Okay, now remember, what does absolute value look like? He's the v, right? So I know we're going to have to be coming up with some v. So the other point that would probably be really useful to me between those that we just found would be the vertex. Well, think every absolute value parent does start at the origin. So just do like we did with the quadratic. Think about your shifts. Okay, would this be left or right 2? Why right? It says minus. Yeah, I remember when you add or subtract, it's the opposite. So that's to the right. And then what direction with the 4? Down. So from the origin, I'd go 2 right, 4 down, and I know that's on the graph. That's the vertex. So then I just go ahead and connect them because I know it's the V shape. So I'll go like this, and I'll go like that. Now, does it make sense that we got a skinnier V shape? Why? What told me I should be getting that? We're multiplying by 3. That would be a vertical stretch. Okay. All right. So we got that one taken care of. And then the only thing left is now my cubic. So this one was A, this one's B, and that's C. Okay. Is anybody having trouble so far? Everybody's able to follow along? No questions? We're good? Okay. Well, let's take a look now. What's one guaranteed point I should plug in, or value, I should say, I should plug into the cubic function? 4. Okay, yeah, use that endpoint. Okay. So I know he wants to be everything 4 or larger. Okay. Oh, looks like I actually went to 5 on that one. My bad. There we go. So he only wants to exist over here larger than 4. We just got to figure out what he looks like. Okay, so I'm going to plug that in. So when x is 4, 4 minus 6 cubed plus 2. Okay, so 4 minus 6 cubed, -8 plus 2. -6. Okay, so we have 4, -6. Is that open or closed? This one is closed because we do have equality here. So 4, -6. Okay. Now, I would probably go ahead and do this. Is the cubic function one of those that goes to the origin as well? Yeah, remember his parent looks like this. Curves up through there. Pretend it goes to the origin. Okay, just can't draw it today. All right. So just use the transformations, like we did on the previous 2. Okay, what are the shifts we notice? Right 6, and then up 2. So I know a point for this graph that started at the origin, 6 right and up 2. And then maybe just to go ahead and finish off the graph, okay, even though we don't have an upper boundary, it goes to infinity, let's just go ahead and choose a value bigger than 6. What do you think? 10? Okay. So let's see here. Let's go ahead and choose 10. So 10, comma. So that would be 10 minus 6 cubed plus 2. So we're going to be a little off the grid. That's okay. In fact, we might as well go ahead and simplify it. So that would be 4 cubed, which would be 64 plus 2, so that would be 66. So, I mean, it's still a good number. It's just, little off what we have here. So you said 7. Let's try that one. Okay. So let's try 7. So that would be 7 minus 6 cubed plus 2. Oh, this one's going to work out much better. So 1 cubed plus 2. I heard 4 and I heard 3. 3. Okay, so 7, 3. Someone did say 4, right? Or am I just old? I could have sworn I heard a 4. What's funny is that person who said 4 is like, no, you're old. That was a joke. All right, we're going to keep our streak going. All right, so what was it? 7, 3. All right. So I would say it's going to look probably something like that. Now remember, on the right, he's going to keep going because he doesn't have an upper bound. Everything bigger than 4. And there you go. I mean, that right there is just a piecewise function. Really, you're just graphing parts of graphs that you've already seen. Is there any question on those? Anybody having trouble? Yes, ma'am. Now, we wouldn't keep going on the bottom because, remember, we do have a lower limit. He doesn't want to exist left of 4. Okay, because otherwise, I mean, he would keep going, just like the parabola would keep going, but we're going to restrict him on these intervals. Okay. Oop. Okay, good. Well, all right. Let's go ahead. Now, the only thing we have left are 2 application problems. This one right here is, very straightforward. Again, like the other one, if you want to take a look at it, I encourage you to. But I would rather look at this one because it's a much, much better example. Okay. This one actually has you think just a little bit. Because the other one's, like I said, really easy. So it says, in August, Orlando Utilities Commission supplied electricity to residents for a monthly customer charge of $8 plus 10.143 cents per kilowatt hour for the first 1,000 kilowatt hours used in the month, and 12.143 cents per kilowatt hour for all electricity over 1,000 in the month. So we have a specific rate for if you go up to it, including 1,000. If you go over that, we've got a slightly higher price. Okay. Now, who are my IB kiddos? Okay, so I only got a couple in here. Okay, so a handful. So this is a lot of times what you're going to see, especially when you take the paper exams. You guys know what I'm referring to? Okay, if you're not IB, then, just kind of tune me out for a second. Don't worry about it. But a lot of times these problems, are progressive. They'll have you find certain values because they're going to be very useful to you later on. Like B is really going to help you with C. Okay, but let's see what happens. It says A, so this is our current problem. We're talking about electricity. So it's our current problem. Okay, all right. Hopefully by the time we finish, it'll make sense. Okay. Maybe at some point I can change your mind about my jokes. I'm going to stop. How about that? Okay. All right. I think Xavier's just about to laugh too hard, man. He's about to just lose it. Okay. He's almost there. Okay, so let's see what it says. What is the charge for using 920 kilowatt hours in a month? Okay, so let's just go ahead and set it up. X is going to be, of course, the number of hours we're using. So that's 920. So let's just say C of X. I'm going to say C represents the cost. Okay, but you can do it however you'd like. So how much is it just as a base fee, even if you use no electricity? $8. Yeah, just to be with the service, you're going to pay $8. Okay, $8 plus. Now we have the rate per the number of hours. So we're below 1,000. So I'm going to multiply 920 times what? So it's the 10 point. We don't do anything to it? Because remember, this is cents. So we don't want to forget to move the decimal. Remember, when you're talking about cents and pennies, it's very easy, when we talk about them. But when we say penny, penny is actually the name of the coin, but cent is actually the value of the coin. Okay, so you just want to be really careful when you're dealing with those. Okay. So now let's see. Hopefully I don't have this already pulled up on my calculator. I do. Avert your eyes. Hey, I got it away just in time. Okay. So let's go ahead and plug in what we have here. 8 plus the 920 hours times the rate we're being charged. And was it, I forgot what it was. 0.10143? 0.10143. Okay. Close the parentheses right there. Oops, not letting me do that. So I'm getting, with the base fee and the 920 hours, I'm getting $101 and... Now, would we want to say 0.316? Now, remember, we're talking about currency. So we would want to go ahead and round to two places. So 101.32. So $101.32. Okay. Now, B is going to start looking at the rate that goes beyond 1,000 hours. But you can't forget about the rate below, because both are going to be applied. So it says, what's the charge for 1,500 kilowatt hours? Okay, so let's go ahead and break this down. C of X equals, now what's the base fee no matter what? $8 plus, now there's one of two ways you could do this. Okay, oh, you already have the idea?
101.
That's exactly right. That's what I was going to go ahead and bring up. You can either go ahead and write it out, because in the 1,500 hours, that's going to be broken into 1,000 plus 500, right? Now, we'd want to do that because for the first 1,000, remember, there's a specific rate. We only get charged this guy right here if we go above the 1,000. So I'm going to take the 0.10143, and I'm going to multiply it by 1,000. Or you could just do what this gentleman was talking to me about a second ago. What's going to happen if I multiply that decimal by 1,000? Yeah, it's going to move the decimal how many places? 3. So wouldn't that be just $101.43? Okay. So right there, if you use exactly 1,000 hours, okay, you're going to pay $109.43. See, we have to use that rate for the first 1,000 plus. Now we want to use the second rate. What is it? I believe 0.12143. But how many hours do we have left to get to the 1,500? 500. We already used 1,000 at the original rate. And then we have the additional 500 at this slightly higher rate. Is everybody okay with that? Okay. So this is actually how you're going to create the function when we write the piecewise function. This is going to help you out with C. But I'm going to go ahead and just kind of streamline this. Remember I said that was just 109.43? So I'm going to come on over here. So delete that. $109.43 plus, it was 0.12143, is that right? Times the 500. Why does it keep doing that? Parentheses. Times the 500. Yep, not 5,000. We're not going to go 5,000 hours. Okay, so I'm getting $170 and what? 15 cents. 170.15. Okay, so this is the amount for 920 hours. That's the amount for 170. Or 1,500, I'm sorry, I was reading the value. Is anybody confused with how I'm reasoning my way through it, Stephanie?
I was just going to ask, how come you moved the decimal? Like in the 101?
Oh, like why did I move the decimal here? Oh, it's one of those, you probably know more about those, like if you're in number sense, is that part of Akadeca? Things like that. Or if you divide by 10, 100, 1,000, then you're going to move the decimal so many places. If you multiply, then you're going to move the decimal. I don't know if that answers your question. It's just one of those little tricks we can use. But, I mean, even if you don't see that, we can just plug it into the calculator. Oh, if we just typed it in like this? Oh, absolutely. Absolutely. Oh, why are we, okay, that decimal, okay. Well, why are we having to move that, okay, I see what she's saying now. So the rate that we have here Like if it's 1,000 or less, it's got us saying 10.143. Okay. Well, think about it. Let's say we do use the 1,000 hours. We're talking in cents. So what's that going to do? If I multiply that number by 1,000, it's going to move the decimal where? 1, 2, 3, right? Okay. So, I mean, LP&L isn't far off, but are we going to go ahead and pay over $10,000 for our electricity? No. See, that goes back to the value, the cent being the value of the penny. We're actually just going to be charging probably a little over a cent per kilowatt hour. And that's the thing, because if I left it as 10 point, because then we're basically charging $10 and something per hour. Does that make sense? And it's important because we had that cent symbol at the end. Okay. I'm sorry, I was confused. I thought you were asking about the other one. Okay. All right. Okay. Any other questions? We get out of here at 52. We have just enough time. Let's try C. Now, this is where you want to go ahead and write a piecewise function. Okay, now I'm going to help you with the two easy parts. It's writing the functions that may or may not be the difficult parts. So for example, you're going to have two functions here. And what's the difference between them? This is going to help me with the interval. What's the restriction for the first one? There you go. X is less than or equal to 1,000. So x less than or equal to 1,000. Because remember, there's a rate specific if you're less than 1,000 hours. And I believe, Jack, you just said it before I started talking. Okay, now you're absolutely correct about that, but there's something we're forgetting about the first interval. What is less than 1,000? What kind of values do we not want in a real-world situation? Negatives. Okay, so are you going to be using negative kilowatt hours? No, that means that basically, in reality, the company would be paying you, and that doesn't make any sense. So we have to cap him at 0. Okay, now we go ahead and put equality because is it possible to not use electricity in a month? It is possible, but it's probably not very likely because even items that are plugged in and turned off, they're still drawing a certain amount of power. I mean, you've also got your fridge running, probably central heating and air, or something in your house. Okay. All right, so take about 1 minute, write what you think those two functions are going to be. Okay, what functions would calculate the amount of money owed for these intervals if you were below 1,000 and if you were above 1,000? And remember, for the above 1,000, use B. Okay, use how we reasoned our way to find the cost on 1,500 to help you write that function. And then I'll write it out and we'll see how we're doing. Time flies when you're having fun, huh? It really does. So I'm guessing math class is probably the fastest class you have all day. All right. So you may not be done, and you probably are not, and that's okay. We're just about to run out of time. So the function, if you're less than 1,000, that's the easier of the two. It should be 8 plus the point, what was it, 101.43? 101.43 times the number of kilowatt hours you're going to use. Okay. And don't forget, about the baseline, because no matter what, even if you use no electricity, you're still paying $8 to be part of the service. Now, the other one, let's see how many people got it. You should be getting the 0.12143x minus 12. Now, I'm already seeing some brows furrow a little bit, so I'm guessing we all didn't get that. Maybe you have the answer, but we didn't just simplify it. Okay, so it looks like I got less than a minute, but let's start here. Let's at least see how far we can get. We got the 8 plus, how much is it for 1,000, the first 1,000 hours? the 0.10143. But remember, we're going beyond 1,000. So to use the first 1,000, we know that's going to be $101.43. Remember, because we already took the rate and we multiplied it by 1,000, right? Okay. It's the other portion where you have to bring in X. Okay, so I'll tell you what, remind me about this tomorrow. We'll go ahead and start there. Thank you very much, guys. You have a great day. I will see you tomorrow. Don't forget, test on Thursday. I'm here 7:45 in the morning if you have any questions.